Hi everyone, for today's lesson, we are going to learn how to write quadratic functions and models given information. So our learning targets for today is for you to be able to say, I can write a quadratic function in vertex form, given the vertex and another point that's on the graph. I can write a quadratic function in intercept form, given the x-intercepts and a point that's on the graph. Finally, I can write a quadratic function in standard form, given at least 3 points using a graphing calculator. So for this lesson, you will need to have a graphing calculator with you. Once again, if you do not have a graphing calculator, I would recommend downloading the free 90-day trial off of Texas Instrument. You can have it doesn't require any money. It is 90 days, so it will get you through most of what we need to get through in this class that requires the graphing calculator. All right, here we go. The first thing we're going to do is we're going to write a quadratic function that's in vertex form. Remember that vertex form is y equals a times x minus h squared plus k. So what we're going to do first is we're going to substitute the values of the vertex in for h and k. So that's the first thing that I'm going to do here. I'm going to write y is equal to, and I'm going to leave a little bit of space for the a value. And according to this problem, my vertex is located at -2, -3. So that means that h is equal to -2 and my k value is equal to -3. So I'm going to write x, and remember that it's always the opposite of what you see, so that's x plus 2 squared, and then -3 is on the outside. Then you're going to substitute the values for the other point in for our function. So if you look at what we have here, the only piece of information that I know from our quadratic is I only know the vertex. I really don't know what the a value is, so that's what I need to find. So my other point that I have is located at 0, 5. And so that value, or these values of 0 and 5, I'm going to substitute those values in for x and y into our function. And now I'm going to solve for our missing value, which is going to be a. So remember to write your final answer in vertex form, and remember that x and y have to remain variables. So what that's going to look like is my x value is going to be 0 and my y value is going to be 5. I just don't know what a is quite equal to yet. So that's what I need to find out. So my y value is 5. This is equal to a, I don't know what that is, times x, which in this case is 0, plus 2 squared minus 3. So I'm going to write 5 equals a times, this is 0 plus 2, 2 squared is 4, minus 3. I'm going to clean this up so this looks like a problem that I'm used to. So I'm going to rewrite this as 5 equals 4a minus 3. So that's just rearranging the numbers in a way that is more familiar. So now I'm going to add 3 to both sides. And when I do that, I end up with 8 is equal to 4a. Dividing both sides by 4, I end up with a is equal to 2. So now that I know that a is equal to 2, I'm ready to write my final answer in vertex form, remembering to have x's and y's back into my problem. So I'm really going to be focusing on the h and the k, as well as my a value. So that is going to be y equals 2 times x plus 2 squared minus 3. And that is my answer. So that is how you write quadratic functions in vertex form, given a point and the vertex. Now we're going to transition to intercept form. So remember that intercept form is y equals a times x minus p times x minus q. And that is where the values, we would substitute the values of the intercepts in for p and q. So the intercepts are our x-intercepts. Then we'd substitute values of our other point in for x and y. And once again, we have to find our missing value, which is going to be a. When we write our final answer in intercept form, we need to remember the x's and y's remain variables. So in this problem, I have two x-intercepts, -3, 0, and 2, 0. So that means that my p-value is going to be -3, and my q-value is going to be 2. The ordered pair that is given to me is -2, -4. That means I'm going to let x equal -2, and I'm going to let y equal -4. What is missing is I don't know what a is. That's what I need to find. So I'm going to write my equation. Remember, the equation is going to be y equals, so y in this case is -4. Y equals a. I don't know what a is next. Times x. X in this case is -2. Minus p. So remember, it's always the opposite of what we see inside. So that's going to be minus -3 or +3. Times my x value again is -2 minus 2. So that is the opposite of what I see here. All right, let's go ahead and clean this up. So this is -4 equals a times -2 plus 3 is 1 times -2 times -2 minus 2 is -4. I'm going to clean up my parentheses and rewrite this problem in a way that I'm more familiar with. 1 times -4 is -4, so I'm going to rewrite this as -4a. Now I'm going to get a alone by dividing both sides by -4, and I find that a is equal to 1. So now that I know what a is, I'm going to use that p and q and my a value that I just found to write my equation. And that is going to be y equals 1, which you can put in the 1. You don't have to, but if it helps you for visual purposes, put in the 1, times x plus 3 times x minus 2. And I was putting in plus 3 and minus 2, remember, because it's the opposite of what we see. And that is my equation. All right, let's go ahead and move on to the next page. So for this problem, it says, write a quadratic function whose graph has the given characteristics. So this is our solo question, and this is what I would like you to have ready to go for the next time I see you in class. I want you to try those problems that we just did on your own. Our next type of problem that we are going to be doing is example number 3, and that is writing a quadratic function in standard form. But this time, in order to write it in standard form, we can't just give you give you a special point and another point on the graph. Instead, we're going to be working with a graphing calculator. And this is where we have y is equal to ax squared plus bx plus c. So the first thing you're going to do is you're going to enter the x values. So you're going to be given a set of ordered pairs. And all of these ordered pairs are on a quadratic function. You're going to enter your x values into L1 and their corresponding y values into L2. So how you do that is, the example says, write a quadratic function in standard form for the parabola that passes through these given points. In order to get to L1 and L2, what we are going to do is we're going to press this button called stat. So I'm going to say we're going to press stat, and then we're going to press edit. So stat and then edit. And what it's going to bring you to is a list. But oh my goodness, I have stuff in my list. I can't have that. That's stuff that I had from a long time ago, and maybe your calculator has stuff in it too. So let me go ahead and quit all of that, and I need to teach you guys how to clear all lists. So to clear your lists or to clear your RAM, I'm going to write clear lists. You're going to press second, then the plus sign, and then you can either clear all lists or you can press 712. So you can press second plus sign and you can go to number 4, which says clear all lists, and press enter. Or you can press second plus sign, number 7, which says reset. Maybe reset might be different on yours. All RAM, I'll say yes, enter 1, and then 2 being for reset. So 7, 1, 2. Now it says my RAM is cleared. And once I go back to stat and then edit, there I go, there's my list. So I went back to stat, which is located below delete, and then I pressed enter for edit. So list 1 is always going to be your X values. List 2 is always going to be your Y values. Verify that it says L1 and L2. Please be careful. So I'm going to say that my X values, and according to this, are -2, 0, and 2. And my corresponding Y values are -6, 6, and 2. So that is how my table is going to look. -2, down arrow, 0, down arrow, 2, right arrow, down again. Then I'm going to press the right arrow and go -6, 6, and 2. And I'm going to press the down arrow. So that here is my list. It's a very beautiful list. And now what I need to do is I need to calculate quadratic regression. So I'm going to go back to stat again. So we press stat again, but this time I'm going to go over to where it says calculate with my right arrow. And we are talking about quadratic functions. So if we were talking about linear functions, linear regression, we would use linreg. But because we're talking about quadratic functions, we're going to use quadratic regression. As we are working with other functions, we'll use other regressions. But regression simply means that we are going to form a function based on data. So I'm going to go down to number 5, quadratic regression, and I'm going to press enter. Some of you might only have to press enter one time. Some of you might have lost your L1 and L2. If you have different L's, like it was in an L2 and an L3, you'll need to just change this list to say something else like second L2 and second L3. But for my calculator, I have to press enter 5 times. And when I do that, I end up with my quadratic regression telling me that my A value is going to be equal to -2, my B value is going to be 2, and my C value is 6. So I'm going to substitute all of those values into my quadratic function. So that is y equals -2x squared plus 2x plus 6. And that is my equation. I would like you guys to please go ahead and try the solo on your own before coming into class. And we have one more example that has context. Here we go. The table shows the horizontal distance in feet traveled by a baseball hit at various angles. The initial speed of the ball at the bat is constant. So these angle degrees are given to us, and the distance in feet is given to us as well. The angle in degrees, because it's on top, will represent our x values, and the distance in feet will represent our y values. What we want to do is we want to create a scatter plot of the values in the calculator. And then we want to answer the question of why would we use quadratic regression. So the first thing we want to do is we need to clear our list. So I'm going to press second, go down to plus sign, and I'm just going to clear my list this time. If I want to clear my RAM, I can do that again, but I'm just going to clear my list and press enter so that it says done. Now I'm going to go back to stat and edit, and I'm going to enter these values into L1 and L2. So L1 is going to be my X values, and that is 10, 15, 24, 34, 45, 48, 58, and 64. And I'm going to go back and recheck my entries to make sure that I entered it in correctly, because there's nothing worse than not entering it in correctly. Looks good so far. And now I'm going to enter in my Y values. So I have 115.6, down arrow, 157.2, 220.8, 269.2, 285.0, which is just 285, 277.4, 244.2, 180.4. And I'm going to go back and check and verify that I entered everything in correctly. All right, it looks good. Everything matches. So now that I've verified my values, I now need to create a scatter plot. So the way that you do that is you're going to press Y equals, and we're going to press the up arrow so that our plot 1 is on, and I'm going to press enter. If you want to, so you want to press enter so that it is on. If you want to check out the settings in your plot 1, you can press second Y equals. We are looking for our plot 1, and then we want to make sure that our type is indeed a scatter plot, and we are using list 1 and list 2. For me, I get a color. Some of you might not get that, and then I like the bigger dot, so that's exactly what I'm going to do. So now I'm going to go back to Y equals, and this time I'm going to press zoom. And because I'm working with statistics, it's going to be zoom stat. And there is my quadratic looking, parabolic looking graph. So I'm going to write down the steps on the side once again what I did. I entered my data into list 1 and list 2, and then I went to second Y equals, and I turned the plot on. So plot 1 on, and then I went to I went to zoom, and then I went to zoom stat. Which is number 9 for me. And then that gave me my very lovely statistical graph. Now, why would we use quadratic regression for this data? Well, that's because the graph or the data values form a parabolic shape. When graphed. So that's why a quadratic regression is most appropriate. So the data values form a parabolic shape when graphed. So let's go ahead and figure out what our sign, what will the sign of our A value be? Well, it appears to reach like a maximum and then turns right back down. So I believe that it's going to have a negative, the A value will be negative. Because the graph is reaching a maximum point and pointing down. So I'm writing the A value will be negative because the graph reaches a max point before decreasing again. Letter C says, find a quadratic model to represent this data. The word model is another word for equation. So we want to write a quadratic equation. So that's going to require us to go back, and we're going to press once again stat, and then we're going to go over to calculate whenever we're coming up with that equation. So I'm going to press stat again, go over to calculate, and I'm going to go down to quadratic regression. I have to press enter a million times. You might have to do something different. But according to my function, I have an A value that is negative 0.177. I'm just going to round to the nearest thousandth, x squared. And then plus 14.651 x, that's my B value, minus, according to this, it looks like minus 20.147, rounding it to the nearest thousandth, negative or minus 20.147. And there is my equation. Now it says the left field fence is 270 feet from the home plate. At what angle or angles to the nearest tenth of a degree will the ball hit past the field? So what we want to do for this problem is we want to look at like a point of intersection. So what I'm going to do is I'm going to go to y equals, and I'm going to put in negative 0.177 x squared plus, like I'm literally putting in my function, plus 14.651 x minus 20.147. And what I'm going to put in y sub 2 is 270. And what that's going to do when I press graph is it's going to give me like a very lovely parabolic shape that appears to be trending with our functions. And what we have in red is the 270. So this is asking at what angle or angles to the nearest tenth of a degree will the ball hit past the field. So we are setting up the equation 270 is equal to negative 0.177 x squared plus 14.651 x minus 20.147. And we're setting up this equation where each side will represent a certain y sub. So this is going to be y sub 2 equals y sub 1, and we want to look for the intersection. So let's go ahead and look at that intersection. So remember that to find intersection, we're going to press second, trace, and I'm going to go down to where it says intersect. And I'm going to press enter. And we want to get as close as we possibly can to 270. So that's 267, 269, 270. That's pretty close. So I'm going to press enter. And the other one, it automatically makes it to 270, and I'll press enter and then enter again. So it's saying that the intersection is at 32.8. So I'm going to write 32.8. So it says at what angle or angles in degrees, so about at 32.8 degrees, and I'm going to write and, so you can't see that, hold on, at 32.8 degrees, and I'm going to do another intersect. Move that cursor all the way over. And I'm trying to get as close as I can to 270. So it looks like this 270.6137 looks as close as I could get. Boom, there's my 270. Enter, enter. And it looks like it's at 49.96, rounded to the nearest tenth is about 50. So that at 32.8 degrees and 50 degrees, the left field fence, it says, if the left field fence is 270 from the home plate, will the ball hit past the fence of left field? So it looks like, will the ball hit past the left field fence? So at 32.8 degrees and at 50 degrees, the ball will pass the 270-foot left field fence. That is what I'm looking for to say. Here we go. At 32.8 degrees and 50 degrees, the ball will pass the 270-foot left field fence. And that is the end of today's lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.